All right, so this video is we're going to be talking about partial fraction decomposition, which is one of the techniques we'll use for integrating. So here's an example of a integral that when we first glance at it, we might think that it could be a du over u, where we'd use u substitution, but the problem is the derivative of x squared plus 2x minus 15 is 2x plus 2, and we just have an x up there. So, and it doesn't look like a trig substitution, so we're looking for another technique, and that technique that's going to help us out here is called partial fraction decomposition. So based on the name, I mean, I don't know if you can tell what that means, but what we're going to do is we're going to break apart, that's the decomposition, we're going to break apart the fraction into two fractions. So, and we're going to do that by based on what we know about adding fractions, which we know we have to get a common denominator. So you're going to go off to the side here, and we're going to write x over, and on the bottom, I'm going to factor it. So I'm going to factor the bottom, and I'm going to get x plus 5 and x minus 2. I think we'll do it. Nope, x minus 3, I mean. Yeah? Because 3 times 5 is 15, negative 15, and 5x plus negative 3x is positive 2x. Okay, so what I want to do is I want to break that into two fractions. So in other words, I'm saying I know that I added two fractions together to get this. So the question is, what are those fractions? And again, based on the common denominator being x plus 5 times x minus 3, that means that we had to have a fraction with a x plus 5 in the denominator, and we had to have another fraction with x minus 3 in the denominator, because that would cause me to have a common denominator of x plus 3 times x minus 5, or x plus 5 times x minus 3. And since we don't know what goes on top there, we're just going to put a little a, which represents some number, and a b that represents some other number. Okay, and so then the idea is, because this is a linear factor, the top would have to be a constant term. Okay. Now, if this would have been a quadratic factor, you'll see some more examples later. But if I would have had like x plus 5 times x squared plus 3, then we would have put an a over the x plus 5 and a bx plus c over the x squared factor. Because the top always have to be 1 degree lower than the bottom. So since this is the first degree, then it's okay for that to be a 0 degree. Okay, so there are a couple special cases of that, but that's the main idea. So then what we're going to do is try to find out what a and b was. So we have an equation here with a bunch of fractions in it. So usually what I do when I'm trying to solve an equation with factors in it is I multiply everything by a common denominator. And I'm not really trying to solve the equation for x, I'm trying to find out what a and b are. But anyway, I'm going to do that same technique, multiply times x plus 5. So I'm multiplying both sides by x plus 5 times x minus 3. The whole shooting match. Now, of course, when I multiply by that, it leaves me with just x. When I multiply by that, the x plus 5 cancels out, and I get a times x minus 3. And when I multiply by that, I get the x minus 3's cancel out, and I get a b times x plus 5. Okay? So now I'm going to try to solve for a. And there's a couple different ways you can go from here. One way is just to multiply everything out, and you find out that you have x is equal to ax minus 3a plus bx plus 5b. And so then I look at the two sides, and I know that I have, on this side, I have 1x plus 0, essentially. And on this side, I have a plus b times x plus negative 3a plus 5b. So when I look at those two equations and try to make them balanced, I know that because of, let me grab a highlighter here, because of this right here and that right there, in order for those two equations to be the same, I know that 1 has to be equal to a plus b. And likewise, because of this right here and that right there, I also know that 0 has to be equal to negative 3a plus 5b. So then I've built a system of equations that I can solve because I remember how to solve system equations. So I think to solve this system of equations, I would multiply the top equation by 3, and I would get 3 is equal to 3a plus 3b, and the bottom would be 0 is equal to negative 3a plus 5b. And if you remember, in this method of solving system equations, I just add the two equations together and I get 3, and that's 0. I get 8b here. So that tells me that 3/8 is equal to b. And so then I go back to one of these equations up here. Since I know that 1 is equal to a plus b, that means 1 is equal to a plus 3/8, because b is 3/8, right? So that means I could subtract 3/8 from both sides, and I get 5/8 is equal to a. So now, remember, I did all this to find, basically what I'm trying to do is break this into two fractions. So now I have two integrals. The first one is a over x plus 5. So that'd be x plus 5 there. And what was a? A was 5/8. So I'll put a little 5/8 up there, dx, plus the other part of this integral was b, which was 3/8 over x minus 3 dx. And so I broke this original integral into two different integrals. And I can go ahead and integrate both of these. And this is essentially a du over u type situation. So this is going to be the natural log of x plus 5 with 5/8 out front, plus 3/8 out front times the natural log of x minus 3 plus c. Okay? So that's the idea for partial fraction decomposition. There is another way to do this if you don't like a system of equations. So let me do a little side note over here. Instead of doing what I did, I could have left them the way they were. And so we're going to take this and try to find a and b over here, okay? So the idea is I say, well, what if, let's let x equal 3 for a moment. Because I know if I let x equal 3, that would make this piece here 0, and I'd be able to find out what b is, okay? So if I let x equal 3, I get 3 is equal to 0 plus 8b. Because when I plug a 3 in there, I get 3 plus 5 is 8. So that'd be 8b. 3 minus 3 is 0, so that just becomes 0. And then, of course, when I put in 3 for x, that's 3. So you can see here, again, I get 3/8 is equal to b, just like we did before. And then to find the a, I do a similar thing. I'd say let's let x equal -5, because that'll eliminate the b. And so then I get -5 is equal to, looks like -8a, right? -8a plus 0. So if I divide by -8, I get 5/8 is equal to a. So some people like that technique better. If you don't mind systems of equations, and this way is not bad. But either way, you got to break it apart into fractions, find your a and b, and then create 2 new integrals. Sometimes there might even be more, 2 or 3 integrals, and then generally you create integrals that you're able to integrate. All right.